What if reality isn't singular? Imagine gazing at the night sky and realizing that what you see is only a tiny fraction of existence. What if our universe, vast as it seems, is just one of countless others, a single drop in an infinite ocean of realities? The concept of the multiverse suggests exactly that. It's a mind-boggling idea that challenges our understanding of space, time, and reality itself. The multiverse isn't just science fiction. It's a topic deeply embedded in cutting-edge physics, philosophy, and cosmology. Today, we'll dive into 10 mind-bending theories about the multiverse that will make you question everything you thought you knew about existence. Whether you're a science enthusiast or simply curious about the mysteries of the cosmos, these theories are bound to leave you awestruck. So let's start unraveling the secrets of the multiverse, one theory at a time. The infinite universes. Theory. Let's begin with one of the most popular interpretations, the infinite universes theory. According to this idea, the universe we inhabit is just one among an endless number of universes. To understand this, think about the universe as an expanding bubble. Now, imagine countless other bubbles forming, each representing a separate universe with its own laws of physics, constants, and particles. This theory stems from cosmic inflation, the rapid expansion of the universe immediately after the Big Bang. The inflationary model, proposed by physicist Alan Guth, suggests that while our universe expanded, other regions of spacetime could have undergone similar expansions, birthing their own universes. These universes could be radically different, or eerily similar to ours. In fact, if the number of universes is infinite, there could be an identical version of you, living an alternate life in a parallel world. But here's where things get even more intriguing. Mathematical probability supports this. Given infinite space, every possible arrangement of particles can and will occur. In one universe, dinosaurs might still roam, while in another, humanity could have developed faster than light travel. The bubble universes theory, a close cousin of the infinite universes idea. The bubble universes theory also originates from cosmic inflation. Think of the multiverse as a giant foam bath, with each bubble representing a separate universe. These universes are disconnected, meaning they can't interact directly. But here's the catch. Bubble collisions might be possible. Imagine two bubbles in the foam merging or brushing against each other. If our universe were to collide with another, the effects could be cataclysmic. Or perhaps, the two realities could merge, creating a completely new universe. Some scientists believe that the cosmic microwave background radiation, the faint afterglow of the Big Bang, might hold clues to such collisions. Could the strange anomalies detected in this radiation be evidence of another bubble brushing against ours? The many worlds interpretation. The many worlds interpretation comes from quantum mechanics and was first proposed by physicist Hugh Everett in 1957. It's a bit like a choose-your-adventure story, but on a cosmic scale. Every time a quantum event occurs, such as an electron spinning up or down, the universe splits into separate branches where each possibility happens. For example, let's say you're deciding whether to watch this video or step outside. In one universe, you're still watching. In another, you're already out the door. According to this theory, all possibilities exist simultaneously in separate parallel worlds. Critics argue that the many worlds interpretation is nearly impossible to prove since these alternate realities don't interact with ours. However, it offers a fascinating explanation for the bizarre behavior of particles in the quantum world, where seemingly contradictory outcomes can exist until observed. The brane multiverse. Next, we enter the realm of string theory, a theoretical framework that attempts to reconcile quantum mechanics with Einstein's theory of relativity. Within this framework lies the concept of the brane multiverse. Imagine our universe as a three-dimensional sheet, or brane, floating within a higher dimensional space. Other branes, each hosting their own universes, could exist parallel to ours, like pages in a cosmic book. The fascinating part? These branes could interact. Collisions between them might explain some of the most profound cosmic events, including the Big Bang itself. In fact, one hypothesis, known as the ekpyrotic model, suggests that our universe was born from the collision of two branes, sparking the energy needed for cosmic inflation. The idea of the brane multiverse opens up wild possibilities. If these branes occasionally come close enough, it's conceivable that particles or energy could leak from one universe to another. Could phenomena like dark matter, mysterious and invisible matter that doesn't emit light, be a sign of particles slipping in from a neighboring brane? The cyclic universe theory. The cyclic universe theory presents an intriguing twist to the brane multiverse idea. What if the Big Bang wasn't the beginning, but merely one of many cosmic cycles? This theory posits that the universe goes through endless periods of expansion and contraction. In this view, the universe ends not with a bang, but with a crunch, a collapse of all matter back into an infinitely dense point, only to be reborn in another Big Bang. This concept has its roots in ancient philosophy, but gained modern traction through theories in cosmology. Scientists like Paul Steinhardt and Neil Turok have explored how colliding branes in higher dimensional space could trigger these cycles. Each collision would act as a cosmic reset button, sparking the creation of a new universe with potentially different properties and physical laws. The cyclic model challenges the idea of an eternal, unchanging multiverse. Instead, it suggests a dynamic cosmos where universes are constantly reborn. This idea might even provide an explanation for why the universe appears so finely tuned for life. After countless cycles, only the most stable configurations persist. The holographic universe. Here's a theory that's both perplexing and mind-blowing: the holographic principle. According to this idea, our entire universe might be a three-dimensional projection of information encoded on a two-dimensional surface. Think of a hologram on a credit card. What you see in 3D is actually stored in 2D. This theory emerges from black hole physics. Scientists discovered that the amount of information a black hole can hold is proportional to its surface area, not its volume. If this principle applies to the universe, it could mean that everything we experience in 3D space is encoded on a distant, two-dimensional boundary. The holographic theory doesn't just apply to black holes. It could redefine our understanding of space-time itself. Some physicists, including Juan Maldacena, have suggested that this principle might reconcile the conflicting theories of general relativity and quantum mechanics. Could we, quite literally, be living in a cosmic hologram? The mathematical universe. Hypothesis. Finally, let's explore a theory that blurs the line between reality and abstraction. The mathematical universe hypothesis. Proposed by physicist Max Tegmark, this idea suggests that the universe itself is a mathematical structure. In other words, reality isn't just described by math, it is math. According to Tegmark, every possible mathematical structure corresponds to a physical reality. Our universe is one such structure, but an infinite number of others might exist, each governed by its own mathematical rules. This idea could explain why the universe is so comprehensible through mathematics. It's not a coincidence. It's a fundamental property of existence. While this hypothesis is highly speculative, it offers a unique perspective on the multiverse. If true, it means that the possibilities for alternate realities are limited only by the constraints of mathematics itself. The quantum foam multiverse. At the smallest scales of existence lies a phenomenon known as quantum foam, a turbulent, frothy sea of fluctuating energy and particles, predicted by quantum mechanics. Within this foam, tiny, fleeting bubbles of space-time continuously appear and disappear. Now, imagine some of these bubbles stabilizing, expanding, and forming fully fledged universes. This idea suggests that our universe could have emerged from such a bubble. It's a tantalizing concept because it implies that universes are being born all the time in the quantum foam. However, these other universes would likely be disconnected from ours due to the nature of space-time, making them nearly impossible to detect directly. While we can't observe the quantum foam at this point, the concept aligns with our understanding of the quantum realm and offers a compelling explanation for how universes might emerge from nothing. The simulated universe theory. What if everything we perceive, the stars, galaxies, even ourselves, is part of an advanced simulation? This theory gained significant attention after philosopher Nick Bostrom argued that a sufficiently advanced civilization could simulate entire universes, complete with conscious beings. If that's possible, the odds might favor our existence within a simulation, rather than a base reality. The simulated universe theory challenges our perception of reality itself. Proponents argue that inconsistencies in physical laws or unexplained phenomena could be glitches in the simulation. Furthermore, the rapid development of virtual reality and artificial intelligence here on Earth hints that we, too, might one day create our own simulated universes, completing a cycle of simulated worlds within simulations. Skeptics, however, point out that the theory is unfalsifiable. There's no definitive way to prove or disprove it. Still, it raises profound questions about the nature of existence and our place in the cosmos. The landscape multiverse. Finally, we arrive at the landscape multiverse, a theory rooted in string theory. According to this idea, the fundamental constants of nature, such as the speed of light or the strength of gravity, aren't fixed across all universes. Instead, they vary depending on the shape of the extra dimensions described by string theory. Think of the multiverse as a vast landscape, with valleys and peaks, each corresponding to a different universe. In some of these universes, the physical constants might prevent the formation of stars, planets, or life, while in others, conditions might be even more favorable than our own. This theory addresses the so-called fine-tuning problem. The observation that our universe seems perfectly suited for life. If countless universes exist with varying properties, it's not surprising that one, ours, happens to support life. After all, we wouldn't be here to question it otherwise. Endless possibilities, as we've seen. The multiverse is a concept that stretches the limits of imagination and challenges our understanding of reality. From infinite universes to simulated worlds, each theory offers a unique glimpse into the vast, mysterious cosmos. But the multiverse isn't just about scientific curiosity. It's also about perspective. If we are one of countless realities, how does that shape our understanding of life, meaning, and our place in the grand tapestry of existence? Now, it's your turn to wonder. Could there be another version of you out there, watching this video, pondering the same questions? Or perhaps a universe where your wildest dreams are reality? The possibilities are truly endless. If you enjoyed exploring these mind-bending theories, don't forget to like, subscribe, and share your thoughts in the comments. Which multiverse theory do you find most compelling? Let us know. And until next time, keep looking up at the stars and wondering what lies beyond.